Okay, Devika, I think you may start.
Okay, cool. A warm welcome to all of you. Today, we have gathered here virtually for the third day of the first ever virtual humanitarian summit, IEEE for Sustainable Future Summit 2020, organized by IEEE PS Young Professionals, Kerala. And I immensely welcome you all to witness this wonderful week. I, Devika Murlidharan, the moderator of today's session, welcome each and everyone present here to the first technical webinar of IFSFS 2020. I welcome all the special guests who have accepted our invitation, the IFSFS team members, mentors, young professionals, and student members of IEEE PSI. And last but not the least, I welcome all our participants, without whose involvement and participation, the event could not be a huge success. So, without making much delay, now let's begin the first technical webinar on electric vehicle for sustainable mobility by Mr. Suresh. So, I would like to hand over the session to Rashid to welcome the speaker. Thank you.
Thank you, Devika.
Yeah, Rashid, you're audible.
Okay, fine. We will one and all. As you know, it's a birthday of IFSFS, and I know you are very excited and eager for today's workshop on electrical vehicles for sustainable mobility. And excellent speaker who suit more for today's session, and it's my pleasure and privilege to welcome our speaker. He is the founder and CEO of Decibels Lab Private Limited, and he the e-learning platform by Decibels. The learning and automotive system for the needful of industry, and he worked on projects Mercedes-Benz, GmbH, Fiat Chrysler. I welcome you, sir. Welcome you, sir, and I welcome all who gathered here. Welcome you guys. Let's start the workshop, and I hope you are having an amazing learning. Welcome to speak Mr. Suraj SD to take upon the session.
Hi, very good evening, and thanks a lot for sharing my brief introduction. It's a privilege to be here. I am pretty much ready and very much excited to kickstart the program ahead from here. So I believe I'm audible to all of you. Is my voice clear?
Yes, sir, your voice is clear.
Fantastic. Thank you very much. Would you give me an access to share the screen? Okay, so waiting for the permissions. Great. So yeah, just another confirmation. I believe my screen. So if so, just confirm yes or no, because I don't want to have a blindfold conversations.
Yes, sir.
Just let me know if my fantastic. Great. So let me start ahead with the presentation. Anyway, thanks a lot for everybody who have joined. It's fantastic to share my opinions towards sustainable mobility, specifically with the EV technology. So I'm sure we are all talking about EV today, and it's very much a buzzing word, and there is nothing much excites than talking about EVs today, right? Because companies like Tesla are, even there are a lot of other startups. Taking an example itself in India, we have Ather, who have like closely raised around 1,000 crores till date with partners like Hero, which means you see a huge commitment itself in the Indian market that we are moving towards e-mobility. And the promising startups like Sun Mobility, which is working on better swappable technology. And there are a lot of other wonderful startups which have got funded by TVS, for an example, like Ultraviolet. There are various number of startups which just go on. We see a huge adoption of electric mobility in India, and we see that is going to be upwind for a certain time. But I think because of the cost and challenges, but down the line, if you see, that is going to be the adoptable technology in India. So that is a different topic all in place, but just wanted to show you the gravity of the whole content. So there is a huge things going on in India itself in the e-mobility segment. So which means there is a huge reason behind it. There could be potential opportunities behind it, and also there will be a huge motive to make it more sustainable as for the energy and also for the whole ecosystem itself. So I'll talk today about very much at a surface level, because going technically deeper will be very tough to touch base on detailed technical topics. So we'll run you through how mobility is very important for us and how is it meaningfully sustainable and what makes it sustainable, right? And then also I'll talk about some of my opinions towards what is going to be the future. And end of the day, there has to be a key takeaway, right? Something that you can take away from this workshop. I will give you some opinions from my side. I don't know what you can do to be the part of this journey, maybe in many ways. Maybe if you want to start a career or if you want to start an entrepreneurship, and because there has to be something as an outcome, right? We're trying to take it away. So I'll give you some judgmental approaches. I believe a lot of you are students who are participating. So I'll give you the direction, and I believe that helps you to making up your next steps. So, okay, so let me just go back to. Right. Right. So sustainability, the three different words we're trying to address today. The one which is like sustainability, right? And then the other one is mobility, and then the EV. So let's understand, like much before we go into like talk of sustainable mobility. So let's understand what is sustainability, right? It's an ability to be maintained at a certain greater level. For example, if you're consuming a lot of underground water for unnecessary purposes, or let's say for a necessary purposes but in an aggressive way, right? Because things can become necessary when we start demanding it as necessary, right? So if we start to consume more water, obviously the groundwater levels will go down. And today, if I see my village where I come from, when I was a kid, and we used to get water like 250 feet if we dig the bore well. Today we have to dig about at least like 950 feet. So it's a very challenging situation, and where we don't know if the water is still available after a lot of time. Maybe after 2 months the water dries out and somebody has to build the borewell again. So same way, if you talk about mobility as a segment, so if we are trying to produce more carbon, and if you're trying to consume more natural resources, maybe it's crude oil or if any other forms of energy, then we're going to end up not having them, and also we're going to end up creating more emissions and pollutions into the atmosphere. And there is going to be sort of a situation where it is irreversible, right? Or you can't do anything to bring back the ecosystem into a situation. So that's what we were worried about, and that's what we don't want to do. And but to make that happen is what is sustainability basically. So we want to maintain that situation very well balanced, that it doesn't go out of your hands, and it always in a recoverable stage. Not to go to the recoverable stage, at least like it is still in the control of what we can make it up. So that's a point of, I would say, sustainability, right? I believe you get an idea. And then mobility. So mobility is something, ability to move, very simply, right? But the thing is, we need mobility. So we can't tell that, okay, our ancestors used to walk or go around and do a trades in a different way. But today we have grown, we have accepted certain social situations, and for that, like mobility has become a dependent part of it. It could be bikes, cars, trucks, planes, and ships, and everything, right? So it is like we have to have mobility. There is no way that we can detach out of mobility, but we want to make that mobility to be sustainable mobility, right? And that is to achieve that, we have something towards EV. So we have mobility through IC engines, right? Maybe petrol, diesel, CNG, and all these things. So what is the challenging situation over there is the emissions are more. It doesn't mean that EV is so pure and it doesn't make any emissions. It's a very incorrect way of telling that. But EV does make emissions. It is not like just zero emissions. It does make emissions. I'll show it across to you. There are possibilities to reduce those emissions, and we try to achieve the part of this mobility right? It's a part of the mobility going towards sustainability. And that is being possible by EVs. That is what we're trying to talk about today. And that's what we're trying to see how this is how it is going to be happening down the line and why every industry trying to be focused towards electric mobility as a part of it, right? So there is sustainability. That is what we want to keep in an ecosystem. But we need mobility, but we want to make that mobility towards sustainability. And for that, we have EV, which we're trying to adopt, and through which we can make this mobility to be a sustainable mobility. Right. So now ahead of it, we'll try to understand how we're trying to make this happen. So why is it so serious for us? And why is mobility itself, like if I go back here, why is this part of mobility being so serious? Right? So why? And we have to like concentrate only on that. Why not industrial pollutions, right? Why not maybe pollutions from some other sources, right? But why mobility? We're trying to be emphasis upon it, because if you don't know the subject, why we're trying to talk about, like you may not actually give a respect to that. You may not appreciate the gravity of that, right? So that's why I have this slide for you here, which talks about why mobility is so important to be considered. The mobility is so important to be considered because it contributes close about 25% of the world's CO2 emissions from energy of combustion from the transport itself, right? So this transports can be like land, or it could be air, or it could be water, right? So what other ways we can mostly expect, right? Only these three, right? So there is a lot of huge percentage, right? 25% is a lot of big number. So, and that means, we need to address that part of segment because there is an elephant in the room, correct? And that's what we're trying to achieve, and that's what we're trying to do. And that's what we're trying to focus, because mobility is contributing a lot in terms of CO2 emissions, right? And then there is another worry, and also it is a good for economy and good for our growth. A lot of us, if we are able to afford cars and we are able to afford personal mobility, right? If you go back 25 years, 30 years back, like I remember my father used to say, if you have to buy a Bajaj Chetak, so you may have to wait for like 3-4 years, or sometime even 6-7 years to make a booking and get the bike, right? So my father used to tell that to me. But if you see today, just you're not even graduate, some cases you already have a car, and somebody just out of the graduation they could afford a car, right? So it means we are being able to have a purchasing power, and because specifically the country like India, China, our lifestyle is improvising a lot in many ways, and we are able to earn more, and with that we want to improve our living standards, right? And if you see that the global population will be living in urban areas by 2050, it means that that is going to be an improved lifestyle, and that improved lifestyle demands personal mobility, and people tend to have that vehicle as an requirement. So then this is going to be increasing 2x the global demand for passenger traffic, could be more than doubled between 2015 to 2050. So that is going to be a huge number. So what we're trying to talk is we're going to have more number of vehicles in the market, more number of vehicles. You talk about emissions not only at the road, right? It's just not you're filling a petrol or diesel, you're driving the car, you're making emissions. But think about all the way back, even production of transportation, like where did the petrol came from? It came from crude oil. So extraction of crude oil, purification of crude oil, transportation of the crude oil, losses in the transportation of the petrol or diesel. Then again, there is a losses in the transportation. Then there's a losses in many other ways. And then at last it comes to your car, and then there's a conversion losses. Then you run it. So it's not just the emissions you're trying to make at your car, but it's also trying to make it all the way down there, right? But you don't realize it. Now, on the other side, if you see about a production of electric vehicle, a production of cars. So again, there's a material, right? Like chassis of the car, engine of the car, like everything, seating system, music system, everything, right? It needs to be manufactured. So again, there is a material required from the core of it, extraction of material, extraction of purification of that material, making that into a raw material, making that into a convertible utilizable material, transportation of it, assembly of it, everything consumes energy. You need to think very big. If they just think driving a car, it just doesn't make any bigger picture for you, right? But all this is happening, so it just a lot of things, in behind and in behind to contribute into your emissions. So maybe you're just trying to see this to be point very much here, right? So you're going to see this as an emission from your car, but that may not be it. This could be an emission because of the losses in the transportation of the fuel. This could be an emission because of manufacturing of extraction of crude oil. This could be a purification of crude oil. This could be the manufacturing of car itself. This could be the extraction of materials to manufacture the car. It's a very big thing. You need to think in that way, and which means we're going to be not making everything sustainably, right? So we're going to be adding a lot of cars, and by adding a lot of cars, you're going to increase the pollution not only at a vehicle level, but also at completely whole life cycle level. And that's what we should be worried about, and that's what is an importance why we're trying to push that towards sustainability. So why EV, right? Why EV is a solution? So that's what we need to understand. Why not IC engines can still be a solution? Why not hybrids can be a solution? Why not fuel cell can be a solution, right? Why not something else can be a solution? Why only EV, right? If you see, this is a typical data graph which is published by, which is a very credible source which you can trust, right? It's a Department of US. I think Argonne National Laboratories, ANL is mean by. So they have published the data which tells about, if you see that how emission levels are going to be for different vehicles. If you see gasoline, if you see CNG based, if you see E85, H2, which is basically a fuel cell technology, and this would be an EV. If you see that electric vehicles are the best among all these things, right? So which means that their carbon footprints are comparatively lesser compared to any of these vehicles. So that is what makes it more optimal to be a solution for the mobility and to achieve towards sustainable mobility. And that is why we are picking up a electric vehicle as a point of it. And we don't believe just the data, right? I mean, we don't just believe because it's just displayed here. So I'm having some numbers here, which makes it a little more meaningful for you. And when we see emissions, right, I already told you, we don't have to see the emissions when you drive a car, right? You don't have to see the emissions. It's we call this is pump, right? And this is car. So it's not like, let's say this is wheel. So it is not just pump to wheel emissions, okay? This is not just a plug to wheel emissions, right? These are words I believe you guys already aware about it. Okay, this is not emissions. That's what we are trying to think through. But this is not all it, right? Where does this electricity comes from, right? It first of all, it just transported all the way from various different sources like method, and then it get produced at some place. And there's a lot of activities which is going on in the whole process of it to produce this electricity, right? And if it is a crude oil, you're extracting crude oil, you're making emissions, and then you're trying to convert that chemical energy into a thermal energy into a mechanical into an electrical, then transporting all that electricity from that place to the plug itself, right? And then you're converting that electrical energy, which is here, which is again AC, and you're going to convert that into a DC because your battery takes DC, right? Because battery stores DC. You're converting that AC to DC again, and then you're storing inside the battery. So battery is your chemical device, right? So you're converting, you're taking a grid AC, you convert it to DC, store it inside the battery. The battery is a chemical, it stores in the chemical format, right? So it's stored in the chemical format, and when it is releasing, it converts that chemical format into an electrical format, and then it releases, and then you supply that to your motor controller, and then you supply that to your motor, and then it goes to your transmission, and then it goes to your wheels. So a lot of these things is happening, right? So you need to account each and every point of it. If you think that you're a sustainable mobility engineer, or you're trying to think EV as an option for your sustainable mobility. So when you look all these details into a place, and there is a very clear understanding of what we're trying to look forward for a meaningful understanding. Let me just rub this out, and it just makes it. I know it's not something I can go in depth about talking each topic. I can just give you a glimpse.
Hello? I think there is an issue with the network. It's not audible. I think there is some network issue. Sorry for the interference. I think the speaker is facing some network issue. We will regain shortly. Sorry, guys.
So dear attendees, if you have any questions, please put it in the chat box. Meanwhile, the research person will join us. He's facing some network issues. Sorry for the trouble caused. If you have any questions, please put it in the chat box.
Okay, yeah, surely, please.
Participants, your questions will be addressed after this session. So if you have any questions, you can please put it in the chat box. The questions will be answered after this session.
Okay, right, guys. So let me go back from here. Was I at this slide? If you just can refer me back in here. Could you please confirm? Was I at this slide? And
Yes, sir, you are in this slide.
okay, great. All right, so going back to the topic to discuss here. So what I meant in this activity is that the conversion of the topic on the slide, which tells us like why EV is an opt solution, that we are trying to prove that the EV is to be the opt solution for an mobility as an option. So how we're trying to prove as a part of this is basically we don't have to only consider the energy from the petrol tank to the car. We have to consider the energy where exactly it is produced, all the way from, maybe this is an example of a hydrogen production. So it is getting produced somewhere all the way. For example, you're trying to convert water into hydrogen. For that, you need an electricity. You're getting the electricity from the thermal power stations or something like that. And again, to produce energy at thermal power stations, possibly are consuming natural resources. that will be natural gas. And again, natural gas is not available locally. You may have to ship that natural gas all the way from somewhere else. So it means that it is not only at this place, it is all the way from where this natural gas is being produced. It is being transported, it is being shipped, and then it is converted into electricity, and then the electricity is transported, and then the energy at this socket has been used for charging of the car, right? And that's what we have to look through, and when you see through this, it makes a more deeper meaningful sense for you. Or else if you see only at this place, it may look amazingly great. EVs are fantastic, but the thing is, you need to see back all the steps to know how EVs are impacting the environment also in the other way, and how the IC engines is impacting, and how we can compare EV to an IC engine. If you see on this part of the slide here, which talks about natural gas to car, and then the second one which talks about the utilization of electricity to run the car, right? If you see the first part where we talk about conversion of utilization of CNG and to run the car, and if you see here, there's a great amount of conversion efficiencies, right? So the compression of it, natural gas recovery, processing, and distribution, and then compression of the natural gas. You transport the natural gas to the car, and then it means the pump, and from the pump you fill the car, and drive the car, right? So which means the thing is, the losses are very less in terms of the transportation. But if you take at the engine, right, the IC engine is very less at its efficiency. So because of it's very less at its efficiency, your overall end outcome will be very, very small, which is about 11 to 22%. But if you take an electric vehicle, right, so you have to produce electricity for the electric vehicle. So it means that you need to use the same way. You're gonna take that natural gas and pass it to the produce a heat from that, and then run your steam turbines, and then you can utilize that into production of the electricity, and then you transport, like transmission and distribution basically, and then you need to convert that electricity into your for the vehicle requirements, which is basically you're supplying an AC here. You need to convert that into a DC, because the battery stores the energy in form of the DC, right? And then you supply that energy to the car, so that AC get converted to DC at the charger, and the DC get converted into chemical energy, right? Lithium, something like that. And then when you want to utilize that, this electrical chemical energy get converted into an electrical energy. So, and then this supplies to the motor controller, correct? And motor controller converts, typically in the electric vehicle we use AC motors. So DC is again converted into an AC at a motor controller. Then it is supplied to a motor, and motor converts that electrical energy into a mechanical energy. Then you supply to a transmission, and from the transmission you go to the wheels. This is all is happening in electric vehicle, and also in the part of your fossil fuel based vehicles, maybe petrol or diesel. The comparative study which you want to make it is, which one is more efficient when we are running an apple to apple comparison. So you're running the natural gas car, you're converting the natural gas into an electricity and trying to run your electric car. Even though if you do that, the biggest advantage of an electric car is it is highly efficient in the energy conversion, because motors today for electric vehicle applications are about 95-96% efficient. Even people are trying to explore up to 97-98% efficiencies. So that means it is a very good in terms of energy conversions, right? But if you compare that to an IC engine, it is very bad, because the energy conversions are like 14 to 26% efficiency. It's like not really good. But for the electric vehicles, it is highly efficient. That's an advantage. So if you put across all the math and compare apple to apple, electric vehicles are about, let's say, 100% up to like 200% more efficient compared to an IC engine vehicles. This is why we call EV as a solution towards sustainable mobility. Okay, and this is what the math makes an explanation. So, but that's what I meant also on the back end picture is, don't just consider EVs are eco-friendly at the vehicle level, okay? But again, you need to produce the electricity for them to run, right? So again, where does electricity come from? That is the biggest challenge today, and we are only able to achieve like thrice the IC engines comparison. But there are a lot of opportunities also. I'll deal them in the next slide. So coming back to the topic here, yeah, coming back to this slide as a presentation. Why is this running? Okay. So here I talk about a bit more technically how we are trying to make it towards sustainability. Okay. The first is a source of energy. Okay. I told you end of the day we need to retain the equilibrium. Right. So for the IC engines, the only source of energy is basically the petrol or diesel. Sorry, it's the petrol or diesel or possibly the natural gas or something like that, right? But if you consider for something like an electric vehicle, so you can produce electricity from, let's say, coal, and you can produce electricity from nuclear, or you could produce it from many other forms of burning of different materials, or you can produce it from solar, you can produce it from wind, right? You can produce electricity from, again, various different natural sources, maybe constructing a dams, right? And maybe if we have natural springs like how we have it in countries like Norway or something like that, you could use that, right? So it means we don't have to be only dependent like petrol, diesel, or natural gas, but for the electric vehicle we need electricity to recharge, and that electricity can be produced from various sources. And again, this becomes not a viable option. But if you see towards this, there is an option available, right? But for the IC engines, you don't even have that option. So that is why it is more a plus point towards sustainability. So you could use renewable sources to charge your vehicle and produce energy from there. So the next is your localized energy production. So the biggest problem of electric vehicles is basically this part of it, right? If you go back here, so this one, where we have a lot of transportation losses, right? We have a lot of conversion losses. But if we try back here, if you try to produce that energy locally, it means at your own house, maybe you can put across solar panels at your house, or set up a small wind station for your village, or a small city sort of a thing, depending upon what is possible. So you can't set up a nuclear power plant, right? It is very challenging, but you can set up a wind farms, or you could set up a solar farms and something like that. So it means the energy is produced locally at the place, and then the same is given to the electric vehicle. So it means you're reducing a lot of your transportation losses, which means it is going to save a huge amount of losses which is incurring for the in the whole ecosystem of well-to-wheel analysis. That is another possibility. But you can't produce petrol or diesel at your house, right? And you can't make that happen. So there is no way. It has a natural resource you have to extract, and you need to, as a crude oil, and you need to do the purification process. But for EV, you can have localized options. Okay, you can use your wind farms, solar farms, and things like that. So the other important thing is the electric vehicles having a lesser components. It means less moving components compared to an IC engines. It means the lesser the number of components, lesser the manufacturing, lesser the material consumption, lesser the transportation, logistics, everything. It means it is going to be lesser in terms of the energy consumption, or I would say in terms of lesser in terms of the energy production, emission production also, right? That's an advantage of having an electric vehicle because it's having a lesser number of components. And less serviceability and material consumption. This is a very important topic, right? Imagine how many number of cars like you have in your cities, right? Like you take a very simple city like Bangalore, like you have at least about 5 crore population, and for that we have about like nearly 1.5 crore vehicles, I think, on the road. So each of them need to be serviced for every 5,000, 10,000 kilometers. How much of oil they consume, right? I mean, how much of any other materials they consume. So all of this becomes a huge contribution towards emissions, right? And because you need to produce this oil, and again, not only produce it, transport it to the like place, store it, and then again when you utilize into the car, you need to remove the existing oil. What are you going to do with that oil? A lot of people just throw that oil, right? It is going to be very bad for the environment. But if you talk about electric vehicle, there is not much of that requirement of serviceability. The maintenance is very, very low. It means that is a very big advantage also towards sustainability point of it. So it's a plus plus. So lesser components, that's a good thing towards sustainability. Localized energy production, that's a good towards sustainability. And then regenerative energy. So the meaning of regenerative energy is, most of you might have been electrical engineers. The motor can be also converted as a generator if we can do certain activities in motor controller, right? So it means when you brake the car, you can convert that waste of energy into a rechargeable energy to the battery. It's a good thing. When you're going downhill, you can recapture that. So all these are advantages for the electric vehicle. When you're an IC engine, when you're braking, that energy is just getting wasted, right? But if you're an electric vehicle, you have an electric vehicle, then that is being plus point for EVs. Modularity. The meaning of modularity is, if you have an electric vehicle, so you can put a small battery pack, you can put a bigger battery pack. It doesn't mean that you have to have the same size battery pack. So it means the vehicle can be very much modular in its size, and it can be adopted for the very different conditions. I would give you a very simplistic example. If you might have heard about, I'll show you some examples here on the vehicles. If you've seen about this vehicle, right? I'll come back to it. I'll come back to these discussions. So if you see, do you think you can develop an electric IC engine vehicle of this simplified? Like the battery is sitting here and the motor is sitting here. So simple, right? I mean, it doesn't really have to be complicated. I mean, to manufacture an electric vehicle. Now, this vehicle, let's say, give you 50 kilometers per single charge. You make this battery a little bigger, so you can give you 80 kilometers, right? This is an advantage and how it can be made as a modular as a requirement. Maybe you replace this wheel and put a little bigger performance oriented, so it can be run quicker and faster into a place. So this is something where I meant as a modular in a way, and it is very simplistic because I showed you how simplistic it is. And in terms of IR component efficiency, I already explained you here. The motor is highly efficient. That is a very big advantage because motor's efficiency, we're talking for the IC electric vehicles, is about 95% efficient, which means they're very good. And nowadays we have a technology of motor controllers, which is highly efficient. And then we talk about battery technology. We're also making improvisations every now and day by day. There's a lot of new technologies coming in the battery. Improvisation in terms of the chemistry, electrochemistry, materials. That is a good wind for I would say for IC electric vehicles. Then there is a very important thing at the end of life cycle. Can we do I would say there's a new term. I'm not sure you might have been aware about it. This term, which we call it upcycling. Okay, the upcycling is basically when a product reaches this end of life. Okay, we call EOL, end of life. Can I use that in any other requirements? Okay, now if you see a lot of your laptop batteries, right? Once we feel that those batteries are dead, we're just gonna get the new battery pack, right, for the laptop. So what the batteries are actually being used for? If they're used for toys. Lot of the toys which you buy for your kids or somebody, those toys are actually having the batteries are upcycled from your laptop's batteries and mobile batteries and things like that. Most of them laptop batteries. It means it is not suitable for a laptop application, but it can be still suitable for applications like a toys. Okay, and even though most of the times not all the cells would have gone bad. Okay, maybe there's only one cells which has gone bad in that series of parallel configurations. So you can use that other cells for your other applications. Same way, if you talk about electric vehicles, once the electric vehicles reaches its end of life, it means we call, this is a technical terms. I'm not sure it's good to discuss because I'm sure you guys are enthusiastic to understand them. If you don't understand, Google it. You'll always can understand. So we call as DOD, depth of discharge for electric vehicles. Okay, so it means, let's say when the battery is capable only to store 80% of what it was supposed to be compared to its original point. Okay, it means your battery, if you recharge the battery after 1 year, it is capable of only storing 80% of the energy what it was storing compared to your day one when the battery was very fresh and brand new. Okay, that means that is the end of life for mobile in automotive applications. So it means when the battery can only store 80% of its capacity compared to its fresh and brand new, then it is the end of life for the automotive applications. It means we can't use it for automotive applications. We have to remove that battery and put a new battery. That's what is the standard we are trying to use in automotive applications today. Again, why it is, how it is, it's a big topic of maybe 5 years of course itself. Coming back to the discussions here, what I meant is this. Now, what you do with this battery pack? You can use this battery pack to store like your home UPS application. So all these electric vehicle batteries are still can be used for another 5-6 years span. Okay, and that is the meaning of upcycling. And you can see a lot of examples of upcycling. People have taken out the batteries. Imagine like Nissan Leaf has about a 20 kilowatt battery pack. It means if you use that battery for your house applications, I mean that is going to serve your house for like much better than any other UPS, right? So that is something we can also apply upcycling and recycle. The second point is recyclability. The meaning of recyclability is this: that once the battery reaches the end of life, what I can use that for, okay? And what I can use it for, because the lithium-ion cells contains a lot of valuable materials. Maybe the lithium itself. So I'll come to that point of bad about battery technology in the next slides. So you have lithium, then you have nickel, cobalt, or manganese, or many of these chemistries. Okay, maybe titanium and many other things, basically, depending upon cell chemistries. You might have heard about what type of cell chemistries, right? We call LCO, LMO, LTO, NMC, NCA. There are various different cell chemistries are available for different applications. So these are all made up of different materials. So when you mean as recyclability, basically you're trying to extract these materials back into its original form. And then when you back it to original form, you can make more number of cells. And because these are rare earth materials, okay, you can't just throw them out. And we're very happy, right? You see a lot of people throwing the batteries into the environment, putting it in the dustbins. You never know what bad it is causing actually, because this could be very dangerous. But the thing is, we need to think recyclability when you talk about automotive, because the regulations are very stringent. Not like using a battery for your clock or using a battery for your mouse or something like that, because we need to be accountable when it is an automotive application. So that's why we can actually do a recyclability, and then actually we can convert that the batteries into materials, and then you can utilize in the next cycling. So this is something, all are plus points for electric mobility applications, and basically that is towards sustainability. Okay, I believe I'm making this session enjoyable for you rather than making it more sort of monotonous and boring. So I believe you guys are able to grasp it. If you have any questions, please drop those questions in your chat box. Okay, I'll be always happy to look at those questions, and we'll be able to try to answer those questions. So if you have any questions, don't hold that question. You can just put that questions in the chat box. I should be able to share the answers across to you. So coming back to the downsides of EV, okay. See, every technology has downside, and we are the engineers to there actually to solve that challenges, right? And if everything is good, why companies hire you, right? And why we need to be the engineers. So that's why we are there to solve the problems, right? Obviously, EV also have problems. So currently, the source of energy, context of India, we still, I would not say not only India, even other countries as well. The energy currently been heavily dependent upon sources like coal, sources like nuclear, and other things. So we need to move away from that, and we need to start adopting towards renewables. That's a very important thing, and we need to also talk about localization of energy production. This is a very important thing when we're trying to talk about sustainability. So it means we have to stop because if you talk about so many vehicles coming to the market, it means there's a huge demand of electricity. I mean, double the requirement of what we have today in the world. Then if you are again producing electricity from the coal, again, coal is a limited natural resource. You're burning the coal, you're making the same mistakes what we have done it in the IC engine segment, right? So we have to think in a different angle and talk about utilization of solar. It is still not cost effective today, but we have to move towards the direction. Okay, because today if you see when 10 years back lithium ion cells about like $1,500 per 1 kilowatt. Okay, today if you see we're talking about $150 per kilowatt, 1 kilowatt. Okay, so it means there's a huge reduction of cost. And same way we should think about solar, we should think about adoption of wind and many other types of it to produce the energy. And that is basically the problem statement and also the solution statement. It is a egg and chicken. We always have to find what is optimal and start towards an adoption point of it. So it means there is a problem with EV too. It means in terms of where we get the energy from, and don't appreciate the EV because it is all looks clean at the road, because it may be making an emissions at somewhere else. Maybe it's a thermal power station. It is emitting ash. It is causing asthma to the people who are living nearby. The ash is going deposited over the plants, and the plants will not do a photosynthesis anymore, and the plants is going to die, and the ash is going to be deposited all over the surfaces of the land. That could be bad to grow the plants, and there is no the lands start to become unfertile, and there's a lot of problems we are also having with EV if you try to produce electricity from this thermals and stuff like that. So you have to move towards it, and that's what you need to think smart. You need to develop solutions smarter in a way that we can make less dependent upon natural resources and move towards more of an independency towards self-sustained options. And the next is cells, materials for cells. I told about materials, like we are trying to use natural, like rare earth materials like lithium, nickel, cobalt, many other materials like this. Okay, and one is there is a speculation that these materials are not extracted in a way where the countries where like Chile and places where people are trying to use child labors and extortions to be as a labors in production of the materials. And again, this is rare earth material, and this is going to be depleting, and this is something as the biggest challenge we're trying to have at a one end. We need to fix that problem, and then we call EV as a sustainable EV. See, I don't want to talk like I'm an EV supportive guy. I talk the truth, and it's up to us to accept what is good. And end of the day, there is a bad, and the responsibility of an engineer is to solve that bad, right? And but it is very good to know what is that bad is basically. Until unless you don't know it, and you always think it is always good, right? Because as a consumer, you may not even get to know what is wrong in the other side, right? So if we come back to the topics of it, like materials for cells, and there is a challenge in terms of again, these are rare earth materials. We need to think in the way what we're going to fix with that, and there is a lot of materials we have to use for the materials itself in a cell. So a lot of research is going on towards organic materials, to be used in the cells itself. That's a good direction. At least we have options to move towards. But in IC engines, we don't have any options, right? And that's a good win towards EV, but that's the problem also currently, elephant in the room to be addressed. If we talk about motors, again, materials, like we are trying to use magnets, natural magnets, right? And that is again rare earth material, and it is available only in specific countries. And you know what happened with COVID and things, we stopped looking towards China, and where China is the biggest importer, exporter of magnets. And that is like, your whole equation just gone wrong for a while, right? But we are trying to use magnets for a EV application, the motor application, because we found them to be a most energy dense materials. And then that's again a problem, right? When you see towards it, we need to fix those problems on the one side. We need to find an alternative motor options, maybe like an induction motor. Again, it's big and bulky. It's an egg and chicken situation. We need to fix that, improvise in the efficiency of it. Maybe other type of motors like SRM being tried and tested out. We need to look. There is a lot of research activities to be in that areas of it, right? When you talk about sustainability as a point of it. So when you talk sustainability, you're gonna be a guy scrutinizing every damn thing which is incorrectly towards consuming more, or towards depleting our natural resources, and excited in a wrong way, and and incorrect approaches. So you're trying to always see through that very keyhole, and that's what you do. I'm trying to blame a lot here, but if you want to be the guy, a sustainability guy, you have to think in the direction, or else everything looks very easy for you, right? Some people install electric charging stations. Oh, that looks great. It's electric charging station. There is no emissions. But where you're getting electricity from? Is that efficient? No, it is not efficient. Then whatever you have made is not good, and there's a possibility to improvise on that. And that's what you scrutinize and you move upon, and you try to fix those problems. And we also have challenges in recycling because not completely the lithium ion cells are recyclable. There is going to be still the problems in terms of the materials, the toxic materials, and stuffs like that. There is going to be some problem. We still need to address the recyclability because in the Indian context, like we know that not only Indian context, in most of the countries too, including. So the cells which we use, right, alkaline cells for our applications like your household applications, maybe for toys or maybe for an applications of your wall clock or your mobile mouses and stuff like that. We just gonna throw those cells, out in the environment, and nobody is scared about it, right? And obviously, it contains a lot of toxic materials. It goes to the water sources, it goes to the soil sources. It going to ruin the environment, and that is what is going to happen. Imagine a lot of these batteries used in EV applications are thrown like that. And these batteries are not small. We're talking about like 80 kilowatt battery pack, 50 kilowatt battery pack, 25 kilowatt battery pack, 100 kilowatt battery pack. We need to think very seriously about recycling them in a proper way. And there is again huge research required in the areas of recycling. And again, to recycle, how much of energy is required, and to recycle, what kind of equipments are required. Again, how those equipments are manufactured. To recycle, do we need some catalyst? Again, what is a catalyst? Is that catalyst a natural material? All these things need to be thought through and look through keyhole. That's how you see as a sustainability engineer. And we talk about safety and electric vehicles. When you're seeing the crashes happening, the lithium ion cells are very susceptible for catching a fire. That is going to be bad for environment because when it catches a fire, it produces harm gases, and that's going to pollute the environment. And again, if it is burned up, and then it's going to releases some of the bad toxic materials to the ground and soil and earth, and that is bad. If it reaches the natural water sources, it is bad. So I mean, this is something challenging, and no technology is 100% good. Okay, as far as you can walk, but it is not possible always. So you have solution, but you need to think that solution to be as good as possible, and that's what we always try to work to make that solutions come into picture. So this is what I see till today as a technology perspective of it, okay, in terms of EVs as an option for sustainable mobility. Great. I believe you got an idea what I'm trying to brief you through why EV is an option for sustainable mobility, right? So I believe that gave you a very fundamental understanding why we're trying to emphasize so much on EV. So let's go back here and talk a bit about a few more slides. I have, I think, other 4 or 5 slides left. These are not big and technical, so I'll run through quick if you guys are bored. So starting with the first thing, what is the basic call? We can talk so much about mobility. We can talk so much about challenges of technology, but there is some fundamental thing we should do it as a human, right? And avoid unnecessary travels. Avoid use when it is necessary, when it is a need. That's a very fundamental thing. And as far as you don't fix this one, no technology can fix us. Basically, no sustainable engineer can fix us, because we will be so stupid enough to keep doing this stuff, and that is going to lead an impact to the world. So this is something a basic call. Like, first and primary importance is this: if you're trying to burn a light and just look through, is it really required? And that's how you see through the keyhole and try to fix something what is happening around you first. So then the rest is the things. So move towards like active transportation. Maybe it's a walking and cycling. It looks very funny, but when I was in US, I used to bicycle to office, and people used to appreciate me because you're concerned about health, and you're thinking not emitting and all these making pollutions. But if you ride to a bicycle here, and people will make fun of it, right? The situations which you have faced across, for sure. I'm not just blaming, because there could be good at few cities too, but we don't have proper infrastructure for bicycling. Like, there is no specific lane which we can call as for the transportation of utilization of bicycles, like bicycle lanes and stuff like that. This is something challenging. And now, if you also see that there's going to be electric bicycles, right, and which we can go up to 25 kmph. That's more than enough here. I mean, in the cities, how much fast you can go on. If you make a mistake, you're going to meet an accident, and that is going to be much bad than making going slower. So, and that is something which is a basic fix which you have to think about. We can't just skip these things and then say, hey, I'm going to fix this. right? First start fixing at a very grassroots level on your own, and then start fixing, up the stream. So then looking for options to utilize your public transportation. There's a lot of needs that need to be fixed by government to, like, not having a very bad infrastructure for a public transportation, maybe ugly buses. This need to be fixed really, somebody need to make themselves feel proud that I'm using a public transportation. Until unless government doesn't create that, and people never appreciate, right? We always feel like it's a not prestigious things to go in a bus, public transportation, and, like, people that doesn't want to wait for a longer time. It need to be fixed, and there is a requirement to go from your house to your bus stop. It need to be fixed. And as far as you don't fix that, and you keep thinking that, I want to become, I want my country to become sustainable. It never can happen in that way. So yeah, those are the problem statements, but we tend to fix them as much as possible by ourselves first, because we can keep blaming on government, how much they could do, right? So, but always I see what I can fix, right? What myself I can do to make that as a first responder. So you could do certain things and try to use towards the public transportation as much as possible whenever it is necessary and needful. And maybe you could also do a carpooling. You could do utilization of technology to do a carpooling and things like that. It makes a sense, right? There are 2 people or 3 people in the apartment. You can go to office together and drop the guy and just go ahead. I know we don't have time, like, manageable timelines at our offices, because people will tell, hey, it worked 1 hour extra, we have to do that. But still, I think that is, like, hypothetically can be worked out, and that's how we should think and fix problems. Because when Ola came, nobody knew Ola is going to be the future, because nobody thought, how can somebody drive a car and that could be so big, right? Big industry. So things has happened, and we never thought, and that has happened. Uber came, and that has happened, right? And the same way, things are like that. When you start, nobody know this is going to be a solution, but when things will start to change slowly, right? And who knew Pepsi could be such a big brand, and they created a market for themselves, even though it is bad for the human health, right? So the same way here too, it could be something we can use technology as a part of it. And then obviously we are trying to improvise towards improved efficiency through vehicle and technology as a part of it. And this is a grassroots, and we're going to go towards it to achieve the basic call of sustainable mobility. And my few opinions as exactly it goes. I think we should think more about, I would say, smaller vehicles, okay, because they make a lot of sense rather than just having the car as a pride. But I think nowadays I would have privileged to show some videos, but limited amount of time, I cannot just show a lot of videos and pictures. So the scooters, which is basically like you have a company called Lime, Bird, all these companies. It's fantastic. It becomes like a privilege to ride in them. It looks more trendy, for the youngsters to use these vehicles like e-scooters, rather than using a cars, like, for individual transportations and stuff like that. Because this is very small, and a physical dimension, right? The fundamental equation. If the mass is more, obviously you require more acceleration to move the vehicle. So it means more force, and more force is basically torque, and torque is basically your current requirement, and current is basically at the battery. So you're basically making it all wrong if you're trying to build up bigger and bigger and bigger vehicles, even though it's an electric vehicle, right? It doesn't make any sense. So I think for a country like India, if you currently look today, the big vehicles are expensive because it requires big battery pack, correct? And battery constitutes about 30% of the vehicle's cost, and up to 50% of the vehicle cost in few cases. So which means more expensive, not good for the Indian economics, right? What is good for the Indian economics is always at a lower costings, right? Because we are a price sensitive market still. So I think this makes a perfect sense, right? Scooters, for an example, right? Or maybe like an example. I may have some images I'll try to show across to you. Like this was an amazing example. I was trying to bring it across. I try using Yulu at most of my travels in Bangalore whenever I can, by the way. And like you have technology, which is here. What is the technology point of it, for an example? So this vehicle is parked somewhere at metro stations. I just need to have a mobile app. I go to the Yulu and I scan the QR, and vehicle unlocks. I can just drive, and I can just park it at next Yulu stop. So basically that's technology, right? And you're trying to make a use of technology and internet, and trying to provide that solution that you never thought of, right? And then the next thing is it's sharing. It's not like only for you, right? It's for many other people. So this guy can use it, this guy can use it, some other women can use it. It's like it's not for one person, right? Because you know about like anywhere between 80 to 94% of times we don't use our cars. They're idle for no use, right? And it means like it's just waste, correct? And because if you take an example of this, not only this guy is trying to use, we are trying to utilize, maximize the utilization of this object, correct? Which means it's good because after end of life, because any object it get corroded, it could eroded, and things will happen. If one person uses it for 15 years, what is the maximum utilization he can do? But if there are 10 people utilizing the same thing for 10, 15 years, that has served bigger purpose, correct? And that is enabling it through sharing. And it is micro, as I said, it means it is belong to this category, correct? Which means it consumes less energy. And then it is most cost effective because it is consumes less energy. It requires less energy for charging. It means it is going to be lesser in terms of the requirements of cost of the charging. Okay, and that's something which I want to bring it across here. Uh, is it visible for you? Is my screen still visible for all of you? Could you please confirm if the screen is visible
Yes,
still?
sir, but the presentation is not visible.
I'm back now. Is it visible now?
Yes, sir, it's visible now.
Okay, thank you. So coming back to the point of it, there are some more options I was trying to run you through, like how people are trying to look through, like micro mobility, medium mobility, and a long distance mobility. And this is a way we should actually look to fix a problem, because nothing is a problem, is a solution for everything. There has to be an very good way of approaching a problem and trying to fix that problem. This is what we're trying to see. If you're trying to go between 0 to 5 miles, try to look around and use these options. Basically that's what they say. 60% of the trips in US are about these ranges. If you're trying to use your own personal car for this one, it doesn't make any good sense, right? And for medium distances and for a long distances, which is more than 15 miles. So this is a way. It means the solution of EV to become sustainable is not only EV as technology, but also about peripheral technology, which is about IoT, or it is possibly about sharing and having that mindset to share the vehicle, and also having the mindset to use that shared vehicle in the right way could lead to a better utilization and better improvement. Coming to my last slide. So what is the takeaway? One is very, very important. Don't blame for 10 other things. I would say we can all blame right now within ourselves to see. So start living for the needful. That's a very important thing. And when you do that, you're basically making yourself good to the environment. That's the fundamental thing. The next contributable thing which you can possibly also do is, if you see there's a problem statement, what you do? You try to fix the problem statement. If you try to find a solution for that problem statement. So the world is great, and the way we accept startups today, like the Aether started in IIT Chennai, and there's a barely as a one scooter manufacturer, scooter project, right? But they had a vision at that time, and then they raised funding. And today, if you see, there's a valuable company in India, right? And like in similar, we have many other examples today. So I think you guys can contribute to not just being this side of it, but being this side is fundamental. Whether you do it or doesn't do it, this side, but this is a fundamental thing. But this could be an value addition which you can contribute as an engineer to the ecosystem. Okay, so that's a takeaway from my side to you. Start building projects, start involving in research, because country needs better EV engineers. We don't have many of them. To tell you honestly, industries are struggling to get good resources. There could be enormous amount of technology development that can be done at a university level and research level to bring that into our industry. So I think the way to go ahead is keep working, definitely involve in some projects, take part in the internship. We are very privileged to be a part of this activity as Decibels. As I'm a founder and CEO, it's quite a privilege for us to be collaborated to this program to provide internships for students who are winning the part of the competitions. So be a part of the internships, take up training programs. As far as you don't invest, you never get something back, right? So you could invest some amount of money, start learning about it. If you're interested in EVs, Decibels is there to help you if you want to learn about EVs and things like that. So this is a good win, and try to be very sportive. There is an opportunity for everybody. You can do a startups. You can also create a good environment around yourself to bring in investors, to make good people to join your company and bring technology solutions to solve the problem. At the end, I would say it's not you personally should do that. It's basically country is asking you to do that. The country needs you to think in a way that you can contribute. And I think if you think in that way, we all will grow and we all will make our country better and better, and bring it to a better shape and stage than what it is right now, to very upper levels. With all of that, I wish you all the best. And thank you very much for giving an opportunity. And I think it's time to take up some questions if you guys have. So this is something, my contact details. If you guys want to drop on an email, you could just drop us an email to that. So I would be happy to sort of connect with you and I'll give you a direction if you have any questions. So let's go back to the part of your QA. If you have any questions to be discussed in the part of your QA.
Actually, we have some questions in the chat box.
Oh, great. Okay.
Sir, when you were leaving the WebEx due to the network issues, we have questions. The first question is from Mufida. Question is, vehicles are major issues in sustainable development. How can we solve these in this modern life?
I'm sorry, can you rephrase the question again, please?
Okay, so the question is, vehicles are a major issue to sustainable development. How can we solve these issues in this modern life?
All right. So, okay, as I said, mobility is a fundamental need today. We can't go back to horse riding. We can't go back to bullock carts and stuff like that. It is a need. I mean, you know it, and I know it, and there is no way we could fix that thing, because we depend upon our lives for so much into it. So you're going to be living with it. So the only solution is what technology we could be adopting ourselves, and how you can make the technology to be sustainable as possible. And that is when we are trying to talk about EV, because it is to be sustainable. It looks to be more promising, and that's the way we are trying to fix ourselves and trying to see what we can do. I think that's the only way. And mobility, as I said, everything, like another day you have to manufacture a car, there's an emission. You can't fix those things. There is nothing can be manufactured without other emissions. But we could try as much as possible to minimize them, and that's what we can do. And that minimization is a very big term and theme to talk about. It could be at every single steps and bits of it. But I think all it requires is how cautiously you could be to make those vehicles to be greener, at every point of it, from the point of extraction of the materials to make them as raw materials and utilize it down the line. I think that's the only thing, and there is no other solutions than that. It's a need. Yeah. Any other questions?
Okay, so the next question is from Senu Hasna M. Sir, why e-vehicles is not being implemented properly? Still, it is not popular in some countries.
Right. So, okay, the thing is, every new technology requires time to adoption, because one is a cost. I would say we don't have electric vehicles which are very much affordable because of the cost of components itself today. So it is going to take some time. That's one of the first primary requirements. Second thing is we don't have, I would say, charging infrastructure which is very well built up. And this is a egg and chicken, I would say, not really the root cause of it, but we could tell that, but there's a mindset behind it. I can tell you, like, there's a range problem. Electric vehicles can only give you like 100 kilometers range. But as I showed you, like, we only travel anywhere between like 30 kilometers to 25 kilometers every day in the city like Bangalore, a maximum of 50 kilometers. But if you charge your vehicle once, you can go for twice. So, but the thing is, we think there's a mindset problem as a point of it. But again, it's also a challenge of technology itself, because we need to avoid the cost of it and stuff like that. And this is some very fundamental things. One is cost. Second thing is in terms of the range and the charging infrastructure. And the third thing is we need better policies. I think still we need better financing options, and fundamentally on top of it, when everything happens, we need to change our mindsets to buy cars and trust in them. And also maybe in the way to look forward is government should look more aggressively in terms of how they can adopt EVs, and also set up more better research facilities, and look forward for a reduction of cost and incentives wise OEMs to make it more lucrative for them in at least in the initial days until everybody adopts. I think these are the challenges on the root level. I think it is going to happen and get fixed down the line.
Okay, thank you, sir. So the next question, in your opinion, is indigenous EV manufacturers like Tata capable of providing electric vehicles and its associated infrastructure in a sustainable way? Are they capable of competing globally?
Right. I think, okay, it's a very good question, because I would have asked the same question when I was in the college days. See, one thing is you need to understand today everything is globally done. Okay. The meaning of globally done is this, that today battery pack for a Tata Motors is possibly designed at a UK facility, and today technology of lithium ion cell is possibly done at China. So we are living in a global ecosystem, and maybe in a way that technology is not just developed here in India. If we talk about components for EV, like power electronics and all these things, it is not that Tata Motors only does it. It is possibly Bosch, Volvo, Continental, Delphi, Hitachi, and many other vendors does it. So like it's a very inclusive thing. Not Tata Motors could develop a whole car and bits and pieces of everything, but they're a OEM. So in a way, if they have a strategy, I think they are competent, and with the global players and partners they have. But it's something we also need to understand in a financial way for the economics which to work out. Everything works under the numbers. So if you're trying to develop something not for your country and not for your market, so it may not be viable for you to sell that vehicle. So that is the way every OEM looks at it first, and where they're competitive, where they're strong, they want to acquire that market first. So that's going to be India. It's a big place, and more number of people are able to earn more and improvise their lifestyles. It means more market is there for India itself. I think that's what they look for. But if you ask me, I think the whole technology is globally developed. I think it is how it is done, because there's a tier 1, tier 2, tier 4 suppliers and stuff like that. So it is that way already. Can they develop? Yes, they can develop. When they can develop, I don't know, because that's the financial decision company takes, and it's the way it goes, because they have investors and they have to satisfy them. It's not just that you won't put your pocket from the money from the pocket to do something, right? And for an example, don't take it personally, by the way. So it's the same thing for them too, and they have to be economically viable and revenue generating. So then that's how they look for, and they will. If you ask me, they're competent enough to do that. Yeah, next question, please.
Guys, any more doubts?
Vivika, I think we have one from Harigo. Okay, I'll read it out. Okay, so the next question is from Harigovind. In your opinion, is indigenous electric vehicle manufacturers like Tata capable of providing EV and its associated infrastructure in a sustainable way? Are they capable of competing globally?
I'm sorry, could you please repeat the question? You broke out.
It was the same question we read earlier. It was the same one we asked.
Okay.
Sir, we addressed this question.
Okay. All right. All right.
So Marigold is asking for any tips or and suggestions for upcoming EV startups.
Okay. Um yeah. So, like the way to think is, I think it's more required. We need to work in terms of technology. Right now, what we stand in India today, and we need to build confidence in the customers. That is the only possibility if we build good technology that to gain a customer's confidence. So we need to have, I would say definitely, I don't undermine when somebody is starting in the very beginning. You all will start with a simple solution and it just grows up. But the only thing is India is a very complex country to address in terms of the product, because we're going to use the same vehicle. Like if you've seen the vehicles, right? Like people, three people will sit, they will carry 10 cans of milk, or they could carry, if you go to a village, like another two weights of grass on that. I mean, it's like very complex to address these things. It means we require a very reliable product, and reliability comes from testing and validation. So when you think about technology and a product, always think to your customer, keep them in your shoes, and seeing the way that you are trying to address them, not address your interest of creating a vehicle. And by that way, the efforts you're trying to put will make the product to come out good, and also will make the efforts to go well utilized for the country. And the last point is, never stop yourself from doing things. It's like the one small step is always required to begin things. So if you feel that you want to do it, the only requirement is how mature do you have thought through to come to take the decision. Because startup is something fantastic, and it is also such a misery, if you don't know how to handle it. And you have to make yourself convinced that what I'm doing is absolutely known to myself. So until that, never step, don't deeply step into it. Be very mature about studies in the market, finding right needs in the market, uh, knowing technology in a bit matured way. I think that is, having a clarity is very important before you get into the startup. And I would say before you get in, and once you get in, it's all going to be a way to make that happen. And then at the last is all the way going to be bring the product into a market. So it's a fantastic thing. It's also a very very complex thing to make that come true. But you never have to stop yourself. That I don't have everything, but if you have a clarity, if you have a vision, if you know what you want to do and what you want to achieve in depth, I think the path is always taken by next and next and next steps. So you may not know what steps you will take, but if you have a vision, I think you will work towards that vision, and you try to achieve that vision. That is what is important when you want to start a startup, and also have a company, or maybe you're at a college level. That is something you need to look for when having a clarity. And we tell, in a way that seek clarity if you don't have it. So have that. I think that's the way to go ahead, and have mentors. Work from early days. You don't have anything to lose if you're working from early days. So that's something good for you. Yep, that's the answer.
Uh, Thank you, sir. So you guys have any more doubts? I hope all doubts are clear. So thank you, sir. Thank you for your esteemed presence. So also for spending time with us and sharing your esteemed knowledge. So we are also looking forward to working with you in more occasions. So by the way, guys, the feedback form will be posted in the chat box. Renita, can you please post that there? There will be session-wise feedback form for every time, so don't forget to fill that. I hope it is there. The feedback form is there in the chat box. Do fill that, don't forget. So now I invite Ashwini DS for the vote of thanks.
Am I audible?
Yeah, you are audible.
Okay, thank you. Good evening, all. First of all, it's my privilege to deliver a vote of thanks on this occasion. On behalf of IEEE's Young Professionals Kerala and the entire crew of IFSFS 2020, extend our sincere gratitude to Mr. Suraj ST, who gave his much valuable time from his busy schedule to grace this occasion on electric vehicle for sustainable mobility. Really, it was an enlightening and informative session. Thank you, sir. A big thank you to all delegates for active participation in the workshop. Further, I take this opportunity to thank all the volunteers who made sincere efforts to enhance the quality of the session. I once again thank everyone whose contribution has made this a successful technical workshop. Thank you. Devika, you can take from here.
Thank you, Ashwini. Thank you. So, guys, thank you, everyone. Tomorrow we have a workshop on Introduction to 3D Printing Applications in COVID-19 by Mr. Shibu Sam at the same time as today. So, just to note, the first and the best 20 out of all the participants inside India will get a chance to get their products printed. So, don't miss the opportunity. And I hope you had a great time. We'll see you tomorrow at the same time. Thank you, everyone. Thank you for being a part of this event.